After the conic curves, now we are going to see the special curves. The special curves are categorized into mainly cycloid curves and involutes. Under cycloid curves, we are having cycloids, epicycloids, and hypocycloids. And involutes, we are going in our syllabus, we are going to draw in square as well as in a pentagon and circle. These are the curves comes under the special curves. Mainly, we are going to concentrate on cycloids and involutes. Right. Now, before seeing how we are going to draw a cycloids and involutes, see some basics, right, for drawing a cycloids. Now, I'm having two circles and one straight line of length 50 mm and circle of 50 mm, right, diameter 50 mm. Now I'm going to split the circle into 8 equal parts. If I'm going to split the circle into 8 equal parts means draw a circle and draw a vertical and horizontal line which passes through the center. Okay, and then take your protractor and fix your protractor like this. Okay, then makes 45-degree here, make 45-degree here. Okay, keep your protractor here and make 45-degree this and keep your protractor upward down, make 45-degree and 45-degree. How I fix my 45-degree means my angle of my circle, total circle is 360-degree divided by 8. What I am getting? 45-degree. If I am going to divide the circle into 12 equal parts means 360-degree divided by 12, I am getting 30-degree. So keep your protractor here and make 30 points, 30 degree from here 0 30 60, this is 90, and from here 0 30 60 and this is 90, and then up or down 0 30 60 90, same as, or from 90 120 150 180 or anything, right? Mark the point and connect those points. I am getting 8 equal parts of the circle, and sorry, this is 12 equal parts, this one is 12 equal parts, and this is 8 equal parts, right? Okay, like this split your circle into 8 equal parts and 12 equal parts. Okay, now I am going to divide this line into, for example, I am going to split this line into 7 equal parts, right? If I am going to divide this line into 5 equal parts means I can easily mark 10 10 10 mm, right? But I am going to divide this line into 7 equal parts means, okay, this is applicable on your conic curves also. If my focus length is 50, okay, and my eccentricity is 3 by 4 or 4 by 3 means you have to divide that into 7 equal parts, right? Okay, that time if 3 by 4 means that is my ellipse, 4 by 3 means that is my hyperbola, right? That time I am going to split this line into 7 equal parts. How means draw a inclined line from this point to 45-degree of distance 70 mm. How many equal parts I am going to split means that into 10. If I am going to divide this line into 8 equal parts means I am going to draw the length of 80 mm. Right. If I am going to divide this line into 9 equal parts means draw the length of 90 mm. Now I am going to split this line into 7 equal parts. So draw the line into in the length of 70 mm and connect the last two extreme points of these two lines. Okay, then split this line into 7 equal parts. That is easy because this is 70 mm line. I am going to split the line into 7 equal parts or 10 10 mm, right? Now then I am going to split this line into 8 equal parts. Okay, now I draw a line and 1 2 3 4 5 6 1 2 3 4 5 6 7 8. I split this line into 8 equal parts. Now I am going to draw a parallel line to these lines. The line is parallel to this line from this point, this point, this point. I am going to draw a parallel line. See, okay, draw a parallel line, okay, to this line. Draw a parallel line and connect those point using scalar drafter. Okay, and now this line will be splitted into 8 equal parts. Okay, right? Now listen, this is my cycloid, epicycloid and hypocycloid. This is some clear, right? If I am having a circle, the circle rolls horizontally, right? The circle rolls horizontally without any slipping. If I am having a point P here, if I am rolling the circle will roll, okay, like this, okay, and again this point P touch the ground on some distance, right? The distance will be a circumference of the circle, and this will be considered as one complete revolution, okay. Just remember these terms, okay. While doing your sums you will know what is this, right? That is the circumference of the circle as well as one complete revolution, right? Now I am going to, if my circle rotates for one complete revolution and for the length of my circumference of circle in a straight line, that is my cycloid. Same way, if my circle rotates for my one complete revolution for my circumference of circle on the another circle, okay, ஒரு சர்க்கிளுக்கு மேலே இன்னொரு சர்க்கிள் ரொட்டேட் ஆச்சு, that is my epicycloid. Hypocycloid means the circle rotates inside the another circle. Circle rotates inside the another circle for one complete revolution and for circumference of the circle. That is my hypocycloid. That means the circle rotates in straight line means cycloid. The circle rotates on another circle is epicycloid. The circle rotates inside the another circle is your what? Hypocycloids, right? Now we are going to see how I am going to construct my cycloid, right? The cycloid, this is in cycloid, the question they are giving only the input value is the diameter of the circle. They are giving some diameter of the circle and draw the given curve, right? And draw tangent number. These are the inputs that are given in your question. First I am taking some diameter of 40 mm and draw a circle, and I am going to divided into 8 equal parts and name it as 1 2 3 likewise, and 8 point, this point again I name it as point number A, right? And then I am going to draw a horizontal line from point 8 of length the circumference of the circle, or the circumference of the circle is pi r r sorry 2 pi r or pi d, right? Okay. For that I will just draw a horizontal line and split the line into 8 equal parts, right, by the inclination method. Already we saw in this video how I am going to split the line into 8 equal parts, right? I split that line into 8 equal parts by inclination method, right? Then after this I am going to extend my point number 1, the horizontal line like a points, and I am going to extend it. Name it as this as 2 dash 3 dash 4 dash 5 dash 6 dash 7 dash and 8 dash. Okay, I am going to extend all this line towards vertically till your diameter of the circle. What is my diameter of circle? It is diameter of circle is 40. So 40 mm, just draw a 40 mm line in all the points like this. I am extending my 1 dash 2 dash 3 dash 4 dash 5 dash 6 dash lines vertically, as well as 1 2 3 4 5 6 7 8 these lines horizontally, okay, till the circumference of your circle. This line comes till the circumference of the circle, these lines comes till the diameter of the circle. Horizontal line I am going to draw till the end of the circumference of the circle from the point 4 as well as 5 6 7. The 5 lines connects your point 3, 6 lines connect your point 2, the 7th line connect your point 1, right? And this the line 6 and 2 is having a the circle center. This line also connects your center of the circle and name it as O, right? I am going to name it my O line. This is your center line and this is your base line. The center line name it as O1 dash, O2 dash, O3 dash, O4 dash and O5 dash, right? Like this, name it your points as O1, O2, O3, O4, O5, O6, O7 or O1 dash, O2 dash, that's up to you. You can name it as anything, but O1, O2, O3, O4, O5 and O6 and O8, name it as like this. And then now see, I am going to take my radius of the circle. In cycloid, takes the radius of the circle. What is my radius of the circle is 20 mm. Right. Fix your 20 mm in your compass from O1 as center. From O1 as center, cut an arc in your first line. This line is what? 1 comma 7 and this line is 6 comma 2 comma 0, sorry, O. 6 line, this line is 5 comma 3 and this line is 4. You need not to mention this in your drawing while you draw, right? I just say it as for your reference. Okay, now this is my 1 and 7th line. Take your O1 as center, cut an arc in your first line, that is radius as distance, O1 as center, cut an arc. Then O2 as center, radius as a distance and cut an arc in second line. And O3 as center, cut an arc in third line. And fourth, likewise similarly 5, 6, 7 and last one comes on this same point. Now I am going to connect all this point in freehand, right? Like this, just draw the cycloidal curve, right? Next I am going to draw the tangent and normal for this curve. For that, fix any point. Okay, fix any point in your curve. I am going to fix this point as P, right? And then before that, you have to name the arc as A1, A2, A3, A4, A5, A6, A7 and this point again as A or A8, right? This point is 8. I am cutting the arc of traveling of this point, right? So I am cutting the name of the arc is A1, this is A2, A3, A4, A5, A6, A7 and A8. Okay, now I am taking this point as P. Okay, now using your compass, fix the radius distance, cut an arc P as center, cut an arc in your center line, right? This line is what? This is your center line and this is your base line, right? Okay, now from here cut an arc somewhere, it comes here and connect this point to your baseline, right? Connect this point to your baseline. Now from this point, from here connect your P point. This is my normal, and draw perpendicular to this one and this is my tangent, right? From here cut an arc in your center line, P as center, and cut an arc of distance is 20 mm. From this point draw a vertical downwards line. I have named this point, mention this point as N. Okay, from here connect N throughout P and this is my N dash, this is my normal. I am going to draw a perpendicular to this one. This point is called tangent, right? And this point is called tangent line, right? Okay.